Lesson 6, Electromagnetism and Magnets. The introduction, page 91. There's a picture on your screen right now of Hoover Dam. And the photo shows Hoover Dam. Water flows down more than 220 meters from Lake Mead above the dam into the Colorado River below. That's 2 football fields from the top of that dam to the bottom, maybe even a little more than that. So it's Lake Mead at the top and it's the Colorado River at the bottom. Every year, the downward flowing water produces electricity for thousands of homes in Arizona, California, and blank, number 1. How is flowing water used to produce electricity? And how is this similar to wind turbines and power plants that burn fossil fuels? In the previous 2 lessons, you learned about 2 forces that act at a distance, gravitational forces and electric forces. In this lesson, you will first learn about magnetic forces and how they cause several familiar effects on magnets and other blank, number 2. Next, you will explore magnetic fields. Understanding magnetic field diagrams will allow you to predict how the magnetic force will affect objects in the field. Oops, that's number 3, field. You will also learn about electromagnetic forces, an effect caused by the interaction between magnetic and electric fields. You will then explore how electromagnetic forces make electric motors and electric generators work. Finally, you will learn about one way that engineers optimize wind turbines to be more blank, number 4. Number 1, page 92, magnetic forces. You know refrigerator magnets can hold papers to a refrigerator door, but those magnets are weak compared to magnets used in industry and science. For example, junkyard magnets lift cars and can be 200 times stronger than refrigerator magnets. How do magnets pull things blank, number 5? Magnets keep things together using magnetic forces. Magnetic forces are attractive or repulsive forces between magnets or attractive forces between a magnet and certain other materials. Common materials that are pulled by magnetic forces may include things made of iron, nickel, cobalt, and certain mixtures of those same metals. Objects that contain any of these materials are attracted to magnets. For example, some paper clips contain iron, so they are attracted to blank, number 6. Now, magnetic forces are non-contact forces, which means that they can act at a blank, number 7. If you hold a magnet near a paper clip, the paper clip will be pulled toward the magnet. The magnet is able to attract the paper clip without touching it because the magnetic forces acted at a distance and pulled the clip to the magnet. Now recall that you have already learned about 2 other non-contact forces, electrical forces and gravitational, blank, number 8. Magnetic forces are similar to electrical forces because both forces can be either attractive or repulsive. Now, I want to read that sentence again. Magnetic forces are similar to electrical forces because both forces can be either attractive or repulsive, plus or minus. Gravitational forces are only blank, number 9. Gravitational forces are only blank, number 9. You can predict whether magnetic forces between 2 magnets will be attractive or repulsive based on how the magnets are positioned as seen in figure 1a. That's the picture right there on your video screen. Each magnet has 2 magnetic poles, which are the regions where magnetic forces exerted by the magnet are the strongest. Let's turn the page. A magnet's poles are called its north pole and south pole and are usually on opposite ends or opposite sides of the magnet. Now, the reading underneath figure 1A is magnetic forces are non-contact forces that can be attractive or repulsive between magnets. Magnetic forces are repulsive between similar poles of two magnets, but are attractive between opposite poles of magnets. And just as a side note, that was just like electrons. Reading on now. The magnetic forces between opposite poles of two magnets are blank, number 10. That means that magnetic poles pull the north pole of one magnet and the south pole of another magnet together. Some everyday objects contain magnets that take advantage of these attractive forces. What examples can you find around your home? And that's question number 6 on this worksheet. The magnetic forces between similar poles of two magnets are blank, number 11. In other words, magnetic forces push the north poles of magnets apart or push the south poles of magnets apart. You can feel repulsive magnetic forces when you try to push similar poles of two magnets together. In fact, as you push the poles closer together, you will feel that the forces pushing them apart are blank, number 12. If you aren't holding the magnets tightly, the repulsive force can be so strong that the magnets may flip so that the opposite poles are next to each other. Figure 1b. The strength of magnetic forces depend on the distance between a magnet and the object that it acts on. The repulsive force between the north pole of these two magnets decreases as the magnets are moved farther apart. Let's take a look up there at magnetic forces vary with distance. When the two ends are real close, you get strong. And down there at the bottom where they're farther apart, they're weaker. Makes sense. The strengths of magnetic forces also depend on the materials involved. For example, a particular magnet may only be able to hold 2 sheets of paper to a refrigerator door because the magnetic materials exert weak forces. However, a different magnet may be able to hold 10 or more sheets of paper up because its materials exert stronger blank, number 15. Now, let's take a look real quick, and if you'd like, and I'm going to read the 6 questions. Number 1, explain how magnetic forces cause magnets and other objects to behave. It's not a long answer. Number 2, how are magnetic forces non-contact forces? Now, you might want to think about number 1 and 2 in terms of a complete sentence, and you might start number 2 with magnetic forces are contact forces, are non-contact forces because. And you might start number 1 with magnetic forces cause magnets and other objects to. And number 3, what determines whether two magnets will be influenced by attractive or repulsive magnetic forces? We just read about that just a couple minutes ago. What determines? Okay, there's a couple different things there. Number 4, just want you to draw an image of attractive magnetic forces between two magnets, okay, where they're attracting each other. And number 5 is draw an image of repulsive magnetic forces between two magnets. So how would you set up two magnets so that they repulse each other? And then on the back of this paper for number 6, make a list of 10 different things that contain a magnet. And be specific. I mean, don't say a car. Yeah, there's a bunch of magnets in a car, but do you know where they are? Be specific. Be specific in your day-to-day life. I think you'll be surprised if you just take a moment and think a little bit. All right, good luck.